So here was our code to draw rectangles. If you remembered, we defined the function with the def keyword, and to the def keyword we passed in the x parameter and the y parameter, which are the starting positions of the rectangle, the width and the height of the rectangle, the color, and the fill color. And the reason we did that is so that drawing a rectangle would be as easy as just calling that function and passing in some numbers and values. Here we're even making it more complicated than it has to be because we were trying to make, print a graph that was of random heights. But all we really needed to do in order to print a rectangle was do something like this. Draw rect, I want it to be at position -100, comma 0. I want it to be 50 tall and 150 high, and I want it to have red borders, and I want it to be filled with yellow. Something like that. And then when I ran it, well, it's still going to do this graph business. I should have commented that out. And there it drew the red bordered yellow rectangle. And getting that to happen was as easy as making one call. Right there. So I'm going to add a draw circle one that looks very similar. I want it to work like this. Draw circ. And I want to be able to pass in the same things, except a circle only has a radius. I guess unless you're making an oval or something like that. So it needs one less number, That's the way I want it to work. So with that in mind, I need to go up and define a function that works like that. And it's going to be based very similarly on the draw rect function. So this is my comment because this is how I'm going to call it. And I'm just going to use that as a reminder. Draw circ. It takes an x component and a y component and a radius component, a color, and a fill color. And a lot of what it does is exactly the same as what draw rect does. I'm going to cheat and copy and paste. Now whenever you copy and paste, alarm bells ought to run off in your head. Copying and pasting is generally bad programming. Maybe it's okay to do once, but if you wind up putting that code several places in your program, you absolutely should encapsulate that code into a function that you can call. And the reason for that is that if there's a mistake in your code, then you have to fix it everywhere you pasted it. Whereas if you put it in a function, you can fix it and it'll be fixed for everywhere that uses it. Okay, so what draw circle needs to do is it lifts the pen so that it can move to a specific position without leaving behind a line. It sets the x and the y coordinates, so it moves it. It sets the heading, not strictly necessary for a circle, but we did it for draw rect. And remember that for turtles, that's 90 degrees, and that's 180. No, that's 0, 90, 180. So setting it to 90 sets it to going north. And then we fill the color. Then we put the pin down. We hide the turtle, we begin our fill, and then we draw whatever we're about to draw. So t.circle with this at the radius. And then we end our fill so that it will be a filled circle. All right, I am going to wind up changing this, so it's totally cool if you're following along, but I'm going to start hacking and slashing it. Let's see if this works. Oh, I want to stop this graph routine. I'm going to come out here and comment out the call to graph. I just want to see my rectangle and my circle go. There we go. Okay. So I could add as many calls to the draw circ function as I wanted to, Make another one. That's at positive 100. And then another one that's at 0, negative 100. And then make another one that's at 0, positive 100. So we'll be drawing 4 circles now. We have encapsulated the ability to draw circles, There's our rectangle. We need to speed this up. Yeah, there we go. So kind of at the 4 coordinates. This is negative 100, 0. This is positive 100, 0. This is 0, negative 100. This is 0, positive 100. So looking at this, there is a lot of common code between draw circle and draw rect. Now we know that because I copied and pasted. But even if I didn't, I could look at it and I could go, wow, man, there's a lot of stuff that's shared between these two things. And then if I was going to draw and add a draw pentagon and a draw triangle and stuff like that, they would probably wind up with shared code as well. So what I need to do is to figure out what makes sense to extract from these functions and put in another function that they can both call. And if I look at it, what they're doing in common is they're lifting their pin up, they're moving to a specific X and a Y, they're setting their heading. They both also set their color, but I don't feel like sticking that in this function. I'm going to make a relocate function that causes it to move to a specific place with the pin up and then puts the pin back down. So it needs to have most of this code in it. Pin up, set X, set Y, set heading. And it needs to put the pin back down when it's done moving. What are we going to call this? Relocate, teleport, I don't know. Anything that means, pick up the pin and move it to a different point. I'm going to call it relocate. And in this case, all it takes is an X and a Y. So now in order to do all that, I can just invoke relocate and pass in an X and a Y position. And I can remove that, or that shared code, from both draw rect and draw circle. There we go. So these functions are shorter now because all of them had to do these 5 lines of code. So these functions have been shortened by 5 lines. And the code that was inside them has been moved up into its own function. So this one calls relocate in order to move, to pick up the pin and move to a different place and put it back down. And so does this one. And then if we want to add, a draw triangle function or something like that, we could add another one, and to do this relocation business, it's as easy as adding a call to relocate. Bless you. Now that I've bragged about it, I'm going to run it and see if it still works. Yeah, still works. Without that relocate, it would leave lines as it moved around. It would look a lot uglier. Let's go and comment out the calls to relocate, and we'll see what it looks like. Then it starts acting like an Etch-a-Sketch, where everywhere you move, it has to leave a line. I say that. Oh, my mistake. Because I commented out the call entirely, it's never changing its position, so it's just executing circle after circle after circle. I'm going to undo those changes and just comment out the pin up and the pin down. All right. So you can see the line, as it moves to each place. Maybe at times we'd like to do that as well, but, we could write another function to do that. So this is an example of how something is easier to fix if it's been broken up into functions. If that code was just copied and pasted it into those functions, and I didn't want to leave that line, I would have to add that pin up and that pin down code to every function that drew. I'd have to add it to the draw rect and to the draw circle. But since they're both in a shared function, a function that's commonly called to both of them, all I have to do is fix it in one place. All right, that's about enough of that, except to maybe think to ourselves, what else could we have moved up into this relocate? How about t.color, change color? Well, conceptually, the idea of relocating yourself is not the same as setting your color. To me, those are two different things. One is moving, the pin, and the other is choosing the color of the pin. So I kind of like those things being broken up. So I'd rather not put this in here because otherwise, every single time you relocate the pin, you have to specify the color. And I don't think that should be necessary. How about hide turtle? Well, I'm not sure why I'm calling hide turtle every single time. We could have moved the call to hide turtle up at the very top. That would make for cleaner code. So I'm going to do that. I'm going to take hide turtle out of both of these functions and just push it up to the top here where we set the width and the speed. Now again, reducing the amount of copy-pasted code. I've managed to get that one out of these functions entirely. These functions are getting really short now. Begin fill. Well, yeah, draw circle really does have to call begin fill. You know, if I want to be, and then you draw the shape, and then you end fill. Yeah, that's cool. This one, the logic for drawing the shape is a little bit more complicated before we call end fill. And maybe we'd want to encapsulate that into some kind of function, but there's really no need to. But what we have done is take the code that both of these things had in common and move as much of it as made sense into a shared function. And the code that made the most sense to put into the shared function was the code that picked the pin up, relocated it, set its heading to due north, and then put the pin back down. All right, if people were typing along to get this to work, let me know if it's broken. I'll come back there and help because I have been scrolling kind of up and down a bit. I'm going to paste this, I'm going to put this code out in the content section. There's no assignment right now that relies on this for credit, so. All right, I haven't heard anybody say they need time to get it working.
Yeah, I'm still trying to catch up.
Okay, sure. If you missed last week, and I don't recall if you did, well,
I was here.
last week everybody was gone. Then it would be a lot more typing. Let me come see.
I just didn't have my code from last week, so I'm starting from scratch.
Oh, yeah. You can get your code back from here, from, well, it's kind of almost too late, but go.
If you remember right, I was one last time for over here.
Oh, okay. So, yeah, if we'd done it, it would have been there. Okay.
I really fast, I put in the wrong spot. Put it in the homework. It's done.
All right. Well, anyways.
I'll get there.
You're going to have to put this up at the top, these lines. And I think what I'll ask is that we wait until the end of the class for you to get the rest. I would print it, but Mr. Printer here is being disagreeable to me. Actually, I'm just going to post this right now. That'll solve the problem. Come on. Really? I know I've made this complaint before, but these computers are, millions of times more powerful than computers 20 years ago were, and they take just as long to load Word, if not longer. Of course, it's because the program Word has gotten more complicated as well. No matter how much computing power they give you, the software manufacturers will use that and make your machine seem slow again. And really all I wanted to do was open this, do a paste, and do a save as. And we've wasted a minute waiting for this to happen. have a feeling somebody's using this computer to discover extraterrestrial life or calculate DNA or something. It's too long to fit in one. Okay, all right. All right. If you refresh your content section, there's a week 8 now. In there is the code I just edited. So if you were heroically trying to type in while I was scrolling up and down, you can get it now.
Thank you.
Sure. So to my recollection, we've done loops. We were in functions. Okay, now we're getting to the good stuff, lists. I want to go back and take a peek, make sure that there's nothing else in functions I want to cover. I don't think there is. PowerPoint, why must you take so long to load? For the same reason Word did. You know, if it was easy enough to swap the cables, I'd just bring in my own laptop. I will give that some consideration. Really, guys? Okay. So when you're writing a function, what you're doing is code generally executes top down. But when you issue a function call, it goes to another, either to another file or another place in your file where you've defined that function. That code executes and then it returns to where you were. So in our code example, you know, we would call drawCirc. The first thing it would do is call drawRect, relocate. It would run all those lines that were in the relocate function, and then it would return and execute the second line of the drawCircle function. And that's what this is illustrating. Passing in a number into the round function. What does a round function do? Well, it rounds it to the specified number of figures and then returns that. So then our code can use that value and processing continues. And in flowcharting, we illustrate a function call, at least a function call to a function we've written, as one of these boxes but with an extra line down the side. So when you call a function, you can pass input to that function in the form of arguments. They're called parameters when you're editing the function. They're called arguments when you're calling that function. So going back to our code here, the relocate function took 2 arguments, 2 parameters now that I'm editing it. Here, these are the arguments that are being passed to the function. Here, these are the parameters. Kind of a goofy distinction. You can kind of use them interchangeably. What is that? That's the x parameter. It specifies the x position on the screen. Y is the y parameter. It specifies the y position on screen. If we were being good programmers, we would document what those are. X is the x position, whatever. Or I could just say x and y are coordinates. And so on. Here I would want to do that and also tell you what the radius and the color and the fill color are. Every function should have a little bit of definition block indicating what it does. Now when I'm throwing code up here, I tend not to document them because that would just be more for y'all to type in. But I should be demonstrating good code. But then it makes, fluffs it up. I have to spend more time scrolling up and down. You can't see as much. So I tend not to do that. Not all functions accept inputs, but for those functions that do, like relocate, you have to give it 2 inputs. You have to give it 2 arguments. If I just try to pass in relocate x and I don't pass in y, that's not going to work. Why? Because when we get up here, it can do this part, it can do the set x, but it can't do the set y because no value is passed inside. So for every parameter here, you have to pass in an argument. The number of arguments and the number of parameters have to match. So functions can receive multiple arguments. It's also possible to have a function with no arguments. I'm trying to think of a function with no arguments. The input function. Quite often we give it an argument, but it's not required. Now, why did I just say that you can sometimes, that the number of arguments has to match? Well, we didn't write the input function, and they probably provided 2 different versions, one that took an argument and one that didn't. In object-oriented programming, that's known as overloading the function. That sounds dangerous, but it's not. It's just writing a function so that it can take different arguments or different numbers of arguments. So that is a function which can accept no arguments, and we've seen that before in when we did something like this. X or print, please enter age. Then we did x is equal to input like that. There. He doesn't have any arguments. Of course, this is a superfluous step because we could have put that right there. We could have passed that in as an argument because that's the way the input function is written. So a function return. A lot of functions will return a value. If they're performing some kind of calculation or if they have processed some data and then your program needs that data in order to continue, then you will return a value. Now in the example I just gave you, this is a bad example of that because we're not calculating any values. What's the relocate function doing? Well, it's moving the pin, but what are you going to do? What could you calculate? There's no math going on in here besides the math necessary behind the scenes in order to, draw stuff. But we have seen functions that return values. We've seen int, so when somebody does this, x is equal to int 1.12, like that. That converts this string to a number and it returns it. We could write a function that returned a value. I'm trying to think of a good one. define, you know, summation, where you specify the minimum value, you specify the maximum value, and then you declare a sum variable, and then you do for x in range, starting from the minimum and going up to the maximum plus 1 so that it's inclusive. That's not strictly necessary. Well, anyways. And then for every x in that range, I think we've talked about loops, so this should look clear. We add that onto the max, and then we return the sum. So summation, you know, that's that big E in when you're writing math, you know, capital Greek looking E. Summation means you go every number in a range and add all those numbers together. You know, like all the sum of all the numbers between 0 and 100, something like that. Yeah. So if we call this summation function and we pass it in a 0 and a 100, it should return all the values added together. So that's why we have a return statement. You don't have to have a return statement if the function is not returning a value. I tend to like adding them just because it clearly demarks the end of that function. But what else clearly demarks it? The fact that you've stopped indenting, you know. So that's why I didn't add return here. But if I was programming for my own sake, rather than show on the screen where I didn't mind wasting extra space, I would put a return statement at the end of every one of my functions, whether it needed a return value or not. You know, that's what it would look like. Another function that's built into Java, the round function, takes either one or two parameters. If you give it one parameter, it rounds it to a whole number. If you give it a second number, it specifies the number of decimal places. So 6.8275, comma 2 should round it to 6.83. That's what would be returned by that function. So somewhere they have some cool little bit of code, probably optimized as all get out, that does the rounding to that number of decimal places, and then at the end of it, there's a return. And we don't see that code. You know, we just call it a function and trust in the force, and it works. Do not confuse returning a value with producing program output. Yeah, these are two different things entirely. Printing is just displaying values on the screen. Returning a value is allowing a value that was calculated in one place in your code to be used somewhere else. And it's possible that you might print it, but you might not. You know, if I was asking the user, you know, for the radius of the circle to draw, and then I had the return radius function, then I wouldn't necessarily print that radius out. They just type the radius in. They know what they did. The black box analogy. A thermostat is a black box. You set the desired temperature. You set it to be either heater or AC or both. You don't have to know how that works. You don't know the inside code of the thermostat. You certainly don't necessarily know, you know, how the heating system works. You don't know how it communicates to the heater. You know, we don't know anything about it. All we know is that there's this little magic box that you pass in a number to it and you say whether you want it to heat or cool, and it magically works. Functions are like that. The functions that Java gives us, we don't need to know how they work. We just have to know what they do. We need to know that the round function can take two parameters and round to a certain number of decimal places. We need to know that the print function, you know, displays data on the screen and that input accepts keyboard input. Now, when we're writing our own functions, we do have to know all this kind of stuff, huh? But then if we give our code to somebody else, if we've documented it clearly, they don't have to dig into the guts of the function in order to understand what it's supposed to do. And, not to belabor the point, the round function takes two arguments, it returns a value. It's rounded to two decimal places because the second argument said 2. Designing your own functions. You want to make them appear as black boxy as possible. And we're kind of violating that in this code a little bit. Because I am creating a turtle outside of these functions, but then that turtle gets used inside these functions. And that's really not the best programming in the world, but I didn't feel like adding another parameter to every function to pass that turtle into it. That would have been better programming perhaps, but it would have made, you know, typing in the calls to it a little bit longer. So, this is assuming that all of the functions in this file, or a majority of them, are going to use that turtle. So I defined it up above our function so that it would be shared. And in object-oriented programming terms, you could call that a member variable. This variable is a member of this, and all the functions here, which are called methods when you're doing object-oriented programming, have access to that variable. That we're not doing true object-oriented programming yet because we're not defining classes, but we will. So even if you're the only person working on a program, making each function into a black box pays off. There are fewer details you need to keep in mind. Ideally, your functions don't need to share data between them. And if they do need to share data between them, then you write it as a class rather than just as a series of functions. So I don't know how to take that any farther. If you have several different functions that are manipulating lots of data between them, it's kind of a drag that you're making those functions tightly linked. You have to call this function in order to have this function ready to work. And we've tried to make this code here so that they're not tightly linked. I can call draw circle and I can call draw rectangle independently of those two things. They do share one piece of data, which is at the turtle itself, but otherwise they are completely separate. You can call draw rectangle and it's not going to mess up the call to draw circle. You don't have to call this before you call this. You don't have to call this before you call that. They are independent. And that's kind of the way you want to make your functions. Sometimes you can't avoid making them have to follow some kind of linear order that they have to be called in. Like if you're going to open a printer port, what do you have to do? Open. That's the very first thing that has to happen, however you're writing your functions. And then you have to send to the printer. Then you have to close. You pretty much know that it's got to be linear like that. But if you can avoid it, you don't want to force the order that the functions are called. So a function to calculate the volume of a cube. What does it need to do its job? What information do you need to know about a cube in order to calculate its volume? Yeah, you have to know its side length. If you were making it a more generic one that wasn't a cube, but was just a box, you would need to know its height, its depth, and its width. But a cube, they're all the same, so you need a side length. And then, what is it going to do? What is it going to answer with? What is it going to respond with? It's going to respond with the calculated volume. So just by thinking it through, we've already written half the function. How do we define a function? The df keyword, volume of cube. What do we need? We need to know the side length. I'm just going to call it side. And what does it need to do? It needs to return the volume. Obviously, this isn't going to work because we haven't calculated the volume. Fortunately, calculating the volume of a cube is really easy. It's side to the power of 3. So now if I want to calculate the volume of a cube, like if for some random reason down here in summation I felt like doing that, x is equal to volume of cube, I would need to pass in an argument like that. Now notice that even though our variable names have been consistent, like x here is x here, and x here, they don't have to be. Because when I was calling this function, I didn't have to pass in something called x. I passed in a number. You can call your functions, your parameters, anything you want, as long as they make sense to you. If I felt like the relocation one needed to be more clear, I might call this x position and y position, or x coordinate and y coordinate. Now I would have to make all the changes appropriate for that to work. Change that to x position, change that to y position. But I didn't have to change the way it was called. Relocate x comma y. When you get up here, this value x gets copied into that parameter, that variable, and this value y gets copied into that variable. Just because they're not named the same thing, that's totally fine. This just gets a value of whatever was there, and this gets a copy of the value that was there. So testing a function. If you run a program containing just a function definition, nothing happens. That'd be like if we wrote our code here, or draw rectangles or whatever, but we never had any calls down here to exercise it, you know? If I don't call draw rect and draw circle, then nothing's ever going to happen. All I've done is define a bunch of functions. So in order to test them, you have to call them. And sometimes you may write a function that all it does is test your other functions. You know, give them the input that you expect and check to see if it is correct. Now, this isn't a software engineering class, but if I wanted to, I could call the volume of cube function with an expected value, and then I could have my test here. If x is equal to 1,000, I've independently verified that a cube of side length 10 is 1,000, then I could print volume of cube works. Else, print volume of cube failed. I have no idea if I've broken my code with all these changes that I've made to it. Please enter age. Yeah, whatever. 10. It looks pretty broken. It's not doing anything. Or maybe it's a drawing. Oh, it really was doing something. And then it says volume of cube works. Because it called the volume of cube function with a value. It got the return value. It stored it in a variable. And then there was a test here to make sure that it was accurate. Now, that's when you're testing your code. You know, when you get your code working a little bit more, you know, maybe you don't need this kind of thing in it. Or maybe you have a function which tests all the functions in your code. I could move this to a function called test and then call that function when I wanted to. So now I'm going to define a new function called test. And I would put in here every function call, I would test it with values that I know were supposed to work, and I would check the return values from them to make sure that they worked. Now that idea doesn't really work for everything, but it works for this kind of math really clearly. You know, so if you're performing calculations, you could always check to make sure that your calculations are working. And the reason why you write a test function that does that is that you can go in and you can add that test function to your code. You know, maybe it runs a test function before it does anything else. And if you've changed something so that it no longer works, you know right away, boom. I've messed up my volume of cube calculation. I wonder what I did wrong. Now, with only one function in here to test, this doesn't look that useful. But, you know, you can write a project that has 10 different functions or 100 different functions, in which case writing a code that performs testing is more important. So testing a function. In order to test a function, your program should contain the definition of the function and then statements that call the function and print the result. I took it one step further. I didn't just print the result, I checked it. I should probably display the parameters and what it returned as well. So I could do that. I'll go in here and I'll say, you know, print calling volume of cube with side length 10. And then I do that. And then I would want to print out what it returned. Returned, comma, x. And then up here, I'm going to make a call to test so that it's the first thing that it does, even before it draws all of its pretty shapes. And it blows up because I forgot my colon. I hate leaving my colon behind almost as much as I hate leaving my liver. Here we go. All right, please enter age, yeah, whatever, 90. Calling volume of cube with side length 10, returned 100. So my test code is showing me what it was invoked with, what it returned, and then some editorial comment, volume of cube works. And then when you're ready to ship your production code out, you could comment out the call to test. You know that it works now. And you can go, okay. User doesn't need to see that, so I don't want that to happen anymore. This is just demonstrating that. They're calling the cube function 2 different times with 2 different parameters. And they're not checking it with any if statements. What I was doing with the if statement is a little bit more of an automated testing. And in Java, it's very common to write a suite of test tools that exercise your program, and it's supposed to do it in an automated fashion. So you are supposed to check the return values, and then if the return value is not what you expect, then you generate an error. Function definition. We know how this works. The def keyword starts our function, or at least it starts the definition of it. You got to give it a name. If it has any parameters, you put those in the parentheses separated by commas, and then you have to have a colon, which begins the code block. And then you have one or more line of code, and then either you have a return statement or you just stop indenting your code. If you want to return a value, you have to have a variable or a constant or something like that, after the return statement. Python is pretty weird in that you can return things in unusual ways that other languages won't support. I'll give you an example of that. I'm going to make a function called silly. It doesn't do anything, but it returns the word goofy, the number -10, and a Boolean false. Now that looks absolutely absurd to any other programming language. But we could do this, and then we would say A, comma B, comma C is equal to silly. And then when we were ready to print A out, print A, it's going to print goofy. And then when we print B, it's going to print -10. And then when we print C, it's going to print false. This is not common between all languages. I really need to get rid of this thing out. Goofy, -10, false, just as we expected. If that kind of bugs you as a programmer, that's totally cool. If that looks totally natural to you, that's great. Just know that this isn't supported in a lot of different languages. Most languages, you can only return one value out of a function. And if you need to return more than one value out of a function, you have to find another way to do it. Function comments. Every function you write should have a little comment block. It should say what the function does. It should say what the parameters do. And it should say what it returns, if anything. So this would be a function block for our cube function. Computes the volume of a cube. What is the parameter? The side length is the length of the side of the cube. The return, it returns the volume of the cube. Now these little @ signs and stuff like that is kind of an affectation here because they don't really do anything in Java. In other languages, you can run a tool which would run through all your code and build a map of all the functions and what they did. And it could produce nice, pretty HTML page about your code, with these little keywords in here, with these little @ symbols. That's certainly not necessary for a good comment block to have those @ signs. Maybe they make it more readable, whatever. I haven't been of the mindset that I was going to count off if you didn't define your functions. If I do slip into that mindset, I will make that known in the assignment. It is good programming. Every program you write should have a comment block up at the top saying what it does, and each function should be documented. That's a professional way to do it. It's not just busy work. Once you hand this code set off to somebody else, which if you do professional coding, you will at some point, most likely, then those functions, those comments become invaluable to the person who has to maintain your code. Or to you if you decide that you're going to write, release a new version, of your game. You're ready to write Angry Birds 3, but you wrote Angry Birds 2 with absolutely no comments. You're going to go nuts trying to figure out what your own code did. Trust me on that. The main function. When defining and using functions in Python, it is good programming practice to place all states into functions, and then to specify one function as the starting point. Any legal name can be used, but we chose main because it is a required function name used by a lot of other common languages, specifically C, C++, C#, Java. And then you must have one statement in the program that calls the main function. And I've given you all code that does that. At the bottom it says if underscore underscore, it has that kind of stuff down there. Here's our example of it. You define a main. And then that code inside main exercises the rest of your functions. And then down at the bottom of your code, you call main. I was making it a little more complicated by putting that call to main inside an if statement. The reason I did that is so that if you imported that function, it would not run main. But if you ran this from within idle, it would run main. And I think that's a better programming practice, because if you write a module that nobody could import, then they may, not get as much use out of it as it could otherwise, so they may have to modify it. You have to define a function before you can call it. This would produce a compile time error. If you say print cube volume 10, and then after that is the definition of cube volume, that's not going to work. Why is that? Because that function has not been defined. It doesn't know how to access this. Some languages let you get around that. Java, for example, you don't have to define a function before it can call it. So you think to yourself, but this example showed me calling a function before it was defined. Here we're calling cube volume 2 and we haven't defined it yet. The reason that works is because the code doesn't start running until it gets down to here. And by the time we get down to here, all the functions in the file have been defined. So these functions can call each other willy-nilly, call each other whatever. Whereas if it wasn't written like that, then you'd have to make sure that your functions were defined at the top. And I've been doing that, like in this code. Pretty much all of our functions, were included up at the top. And I did not intermingle those with code that actually ran. I probably did in the thing that did the ask, the input function, which, come to speak of it, that needs to go bye-bye. All right. So order is important. If you do the idea of the main function that calls the other functions, then that eliminates this problem, because all the functions get defined before main is invoked. It's a very good reason for using the idea of main. However, a function be called from within another function. The following is legal. You could define main. It could call cube volume, and then this is defined in another function. That works because we have invoked main from down here. So by the time we get to this point in our code, this function has already been defined, so it can be used within this function. And if that bugged you, if you didn't like the way it looked, you could always cut that out and paste it and put it below. Our minds, once you get used to the idea that the code has to be defined before you can call it, like this better, or at least mine does. I see my cube volume function, I know it's called by main, and I know that's called there. But these can actually be in the opposite order. Parameter passing. The parameter variables are the things that receive the argument values. The argument value could be the contents of a variable. It could be a literal value, like a 2, in our code here. In some places, we were calling functions and we were passing in variables, like relocate. Here I was calling relocate and passing in the values of variables. Here I called a function volume of cube, and I passed in a hard-coded 10, which is known as a literal. So they can be either, as long as they match the expected type. This is going to break the program pretty fast if I try to pass in that. Why? Because the volume of cube function is expecting a number so that it could calculate a volume, which is another reason why you need a comment block. What does this thing do? It returns the volume of a cube. What is the side? Or as they were doing it, add side. Must be an integer or a float. You can document it so that somebody who's using your code knows what kind of parameters to pass to it. The parameter variable is declared in the called function. Well, it's defined in the header of the function. It's initialized with the value of the argument value. So when we called the function, we pass something in, and then inside the function, the parameter variable gets that value. The fancy word for that is formal parameter. Here we go. Result 1 is equal to cube volume 2. This is the argument. When we get down here and we watch the code start executing, in our mind, this is the parameter right here, side length, and it gets filled in with the value 2. So then when volume is equal to side length times 3, that's not right, it's times 3. Then, at that point, it'll be 2 to the power of 3, and that value will get returned. Common errors. Trying to modify parameter variables. You can do that, but it doesn't actually work. If I go in here, well, here, and this is a good enough example. They've written a function called add tax, where you pass in as arguments the price and then the tax rate. It calculates the tax based on the price times the rate. Here they add something onto it. The price is equal to price plus tax, and then they return tax. Now this is stupid because this doesn't make any changes. Whenever you call add tax, this is not going to have any result. And what I mean by that is now that I'm ready to call it, add tax, and I want to find out what the tax rate is of 100 at a 10%, $100 at a 10% tax rate. And so then I want to print it out. This variable here is just a copy of whatever was passed in. So although we've made a change to it here, it's not worth a hill of beans. Because down here, what, is this number 100 going to change to something else just because we did that line? No. So although it doesn't consider it a syntax error for you to try to change the value of the parameters, then once you leave that function, those changes are lost. Another example would be, suppose I had a variable called P that was supposed to contain the price, and a variable called T that was supposed to contain the tax rate. And so I call add tax with these two as our arguments. When I'm done, is P going to have been increased? This code makes it look like it's going to. It's going to calculate the tax rate, and then that tax is going to be called and added to the price. But it's not going to do that. Well, I can't prove it because I didn't print it out, and there's all sorts of other changes in here now. Or I've totally broken this code with all the changes I've added. But if we printed out P after this call, the value would be exactly what it was before. And the reason for that is because Python is what's known as a pass-by value or pass-by copy language, meaning that when you invoke a function or a procedure, whatever you pass in there is passed by copy. It's not the original. So when we pass P in here, price is equal to 100 because that's what we passed in. But if we set it to 0 or negative 100 or whatever, that doesn't change this because it's just a copy. It's like I wrote the value 100 on a piece of paper, and then I passed it to Londell, and he wrote on the piece of paper himself, But that's just a copy of it. I had the original. Programming tips. Do not modify the parameter variables. You can, but don't. And what that means is don't change these values here. If you're passing in a price and you're passing in a rate, your function should not modify those. Just because it makes the code more confusing. It's not like it's going to actually change that variable as far as this is concerned, but it's bad, it's tacky. It's like wearing last year's fashions. Return values. Return functions can optionally return, and it's about time to stop. Multiple return statements. That's just what I was showing you. You could pass back multiple values. Well, that doesn't illustrate it. All right, we're going to stop here rather than me rush through that at 90 miles per hour. We do still have homework waiting for us, I think. Chapter 5, functions. Yeah, so that's timely. Looks like they're doing 2 weeks. Okay, so that's perfect timing. All right, go ahead and take a stab at this, read up on Chapter 5 or whatever. We'll lecture a little bit more on Chapter 5 next week. And then the week after that is when I'll open up the exam for the take-home exam, so you have a week to do it.